guys. So this will be our last session of the semester. This will be the final review. And so right now, you see right here is problem one, moment of inertia. So for the concept that's in the front of this review, I post that video from last semester because it's pretty much the same thing. The only difference that the only thing that he didn't cover was just the internal force, which I'll explain to you when we get to that problem. But other than that, all the concepts are the same. So I think you guys can just use that video to just reviewing the reviewing of those concepts, those kind of problems that's going to be on the final exam. So right now, let's just get straight into the problem. So to save time, I set out those tables for moment inertia because I know it takes time to do that. So I'll just set it up. So we know that. Okay, so let's read the problem first. So the problem one says, determine the moment of inertia for shaded area shown with respect to x-axis and y-axis. Okay, so as we can see right here, if we think about the whole structure is a rectangle, right? With a width, which is b equal to 5 inch and a height of 6 inch. So what we can do is that we can consider that a whole rectangle as a whole, and then minus what are the empty areas. So for the example, in this case, I said this whole rectangle, that's called a segment one. Oh, sorry. It's called segment one. And then for the rectangle up here, let's call it segment two, and the rectangle right down here, let's call it segment three. Okay. All right, so let's find out the area. So for segment one, we know that it's going to be the area. We know that for rectangle is going to be the length times the width, which for the first one would be 5 multiplied by 6. Sorry. For segment two, we know that it's going to be 4 multiplied by 2. And segment three, 4 multiplied by 1. Okay, and then let's find out the x bar. We know that x bar is the central distance from the x-axis out. Okay, so in this case, we can see that there's no distance from x-axis out for any of the segments. All their center is about the center of the x-axis, which is about the origin. There's no distance out, so there's no x bar for all of them. And then for the y bar, we know that it's from the y-axis out. Okay, as you can see right here, for segment one, it's just about the origin, so it's going to be 0. And then for segment two, you take that 1 inch plus the half of the 2 inch, which the total y bar right here will be 2 inch. And then for segment three, same thing, take that 1 inch plus the half of the 1 inch, which will be 0.5. So add them all together, you get 1.5. Okay. And then next thing, let's find out what Ix bar is. So we know that for Ix bar, for rectangle, we're going to use those two formulas right here, where for Ix bar, it's going to be the width times the height cube divided by 12. And then for the I bar y, which would be the height multiplied by the width cube divided by 12. And please note that this is only for rectangle. Okay, I'm sure that he will give you guys a table of moment of inertia where there's different I value for different kind of shape, but this one is just for rectangle. Okay. So let's do it. So segment one, the width is 5, the height is 6. Don't forget that cube divided by 12, and we get 90 inch to the fourth. And then for segment two, the width is 4, the height is 2. Don't forget the cube divided by 12, get 2.67. And then for segment three, we have 4 multiplied by 1 to the cube divided by 12, and we get 0.33. Okay, and then for the I bar y, same thing, but you just flip the height and the width, and then don't forget the cube. And I'm just write it out. ix is 4. Okay. And then once you find the ix bar and iy bar, now you can compute ix and iy by applying this formula right here, where ix will be ix bar plus the area of that segment multiplied by dy. Okay. And then dy, we know that that's the centroid of the entire thing to the centroid of that segment, which I'll explain to you while we're working out that step. So let's do it for segment 1 first. Trace a color. Segment 1. So ix will be equal to ix bar, which is 90, plus the area, which is 30. Okay, and then multiply by dy. Okay, dy in this case, like I said, dy is from the centroid of the entire object to the centroid of that segment, which since for this question, the centroid of the entire segment, I mean, for the entire object, for the entire thing is right here at origin O. Okay, and we know that for segment 1, since this is the entire thing, so we know that the centroid is also about the origin O. So there's no dy. And basically, for this kind of problem, you can basically say that dy is equal to the y bar, which will be 0 squared. So it will be just equal to 90 inch 4. And then for iy, we have I bar y, which is 62.4 plus the area 30, and then plus the dx. Like I said, for this kind of problem, you can basically say that the dx is equal to the x bar, which will be 0 in this case. So you get 62.5 inch 4. And then for, let's say for segment 2. Segment 2, the I bar x, which is 2.67, plus area, which is 8, multiplied by the dy, which will be 2 in this case, square. You're gonna get 34.67 inch 4. And then iy, we got 10.67 plus a, okay, multiplied by dx, which will be 0 in this case, 2, 10.67 inch to the 4. And then for segment 3, the ix will be 0.33 plus the area, which is 4, multiplied by dy, which will be 1.5 in this case, square. We're gonna get 9.33 inch 4. iy, we get 5.33 plus 4. Since dx has to be 0, just gonna be 5.33 inch 4. Okay, and let me just scale down this. It's too big. Okay. All right. So next thing up, we can find out the ix. Like, remember, like I said, we consider 2 and 3 as not empty object, as a filled object. So that, but right now, but we know that they are empty space right there. So in this case right now, we have to take the entire segment, which will be 1, and then minus the empty area of 2 and 3. So ix will be ix1 minus ix2 minus ix3. So you get ix equal to 46 inch to the 4. Okay, and then same thing for iy. Gonna get iy equal to 46.5 inch. Okay, they're pretty close. Okay, so this is our answer right here. And guys, this is a type of problem that he likes to throw on the final for Moment Alicia. So you expecting to see something like this to be on the final. Okay. All right. I'll see you guys in the next problem.